All right, let's get some more examples. How are you doing, October? All right, she fell asleep. Maybe a bad sign. Hope you didn't fall asleep. So we've got this lovely table, which has no typos in it whatsoever. We're going to use the same data as before. Okay. T is the number of years after 2014, and T is going to be the average cost of a gallon of gas in dollars. So part A says, use that formula we did before to find the average rate of change between 2015 and 2020. You can think of this as the time like post fall. There's a few things that happened from 2014 to 2015 that caused this big fall in gas prices, and pre-pandemic, so that 2020. So the average rate of change, we have the formula from before, and we can use any of these versions of it, right? We can write any pair here. They're all equal, so any pair will work. We can look at the change in y over change in x, or we could use y2 minus y1. Any of those formulations, they'll all give you to the same place. Let's use this formulation for average rate of change. And we're looking at 2015. That's going to be t equals 1, because t is how many years since 2014. And 2020 is going to be 6. That's 6 years since 2014. So this is our x. This is our first x. This is our first y. This is our second x, and this is our second y. When we say y2 or y sub 2, that just means the second y. Y sub 1, the first y. Sometimes we'll say y1. Now we just replace the formula. Y2, we said that was 2.45. Minus y1, we said that was 2.99. Divided by x2, which is 6, minus x1, we said was 1. So as soon as we can identify which one's the first x, which one's the second x, and it actually doesn't matter which one we choose as the first. I usually do left to right, but it doesn't really matter which one is chooses as the first. And if you don't believe me, try switching them. Have this be x2 and y2. You'll get the same answer. All right, so we just type this into the formula, follow order of operations, and then we're going to get our answer. So when I'm going to use a calculator because I don't trust myself. All right, so if we use a calculator, we're going to get, I already forgot the numbers, 2.45 minus 2.99. I'm going to use parentheses so that when I divide, it divides the whole thing. 6 minus 1. So it should look about right. And we'll get negative 0.108. So what that means, and we have to interpret our answer, anytime you have average rate of change, if you just have a number, the number doesn't mean anything. What are the units of the number? Output units divided by input units. So the output units is going to be dollars per gallon. The input units are going to be years. So dollars per gallon per year is how we answer. So, and it's negative. That means it decreased. Again, negative means it's decreasing, or it decreased in the past. So we can combine our answer to say the average rate of change between 2015 and 2020 is a loss or decrease of 10.8 cents per gallon per year. All right, that's one way that you can write it. You could also have written actually 10.8 cents per gallon per year. That would be fine too. Wait, we write dollars before the number. Do we write cents before the number? I don't know. You could also write it like that. Okay. And again, that doesn't mean that every year the cost of gas is going down by 10 cents, right? Because it went down and then it went up and then it went up and then it went down and then it went down. Just says, well, okay, if we average it out. it's going down about 10 cents every year. Okay, so it's a very broad statement, just so we can get the general trend over that time period, but it's not going to be exact and it's not going to tell the whole story. So pause the video now and try to find the average rate of change between 2020 and 2022. Should be very similar. So I'm going to erase my labels here because we have different points now. 2020 is still t equals 6. 2022 is over here. So now we're looking at the average rate of change during the pandemic. It's going to be a little different. Also, something happened and started in 2022 that also affected the cost of gas. I'll let you fill in the blank there. Okay, so average rate of change, going to be the same formula. The second y minus the first y, the change in y, divided by the second x minus the first x, the change in x. And so you probably had this as your first x. But I want to show you that it actually really doesn't matter. Let's say we have this as our second x and our second y, and our first x and our first y. Doesn't matter which one's the second one, as long as you're consistent. But usually we choose the first x as the one on the left. So now if we use this formula, we're going to get the second y is 2.45 minus the first y, which is 4.90. Second x we said was 6, and the first x we said was 8. We type that into a calculator and see what we get. 2.45 and 4.90. Divided by 6 minus 8. We get 1.225, which is probably what you got as well. That on average, so before the average was negative, the cost was going down every year. Well, during the pandemic, the cost of gas was going up about $1.22.5 every year. Okay. You could say between 2020 and 2022, gas prices increased by about $1.22 or 23 cents, or you could include the decimal per gallon every year. So notice that my actual sentence structure here is pretty different than my sentence structure in the answer for part A. I would take both of these sentences, but I would actually say that the sentence structure I used in the bottom is better. This one's good, but this phrasing is better. All right. It sounds a lot more organic, a lot more natural. The top one sounds like it was written by a mathematician who doesn't know how to speak English. Doesn't know how to communicate. Not specifically like English, but just a math person, and there are a lot of us who don't know how to communicate. But the bottom one sounds much more normal, okay? Like someone who actually knows how to talk to you guys. Hopefully that's what you got. Let's look at example 2 now. Given the function, find the average rate of change on the interval from 0 to 3. Okay, well, let's do the same thing. Average rate of change is going to be the second y minus the first y divided by the second x minus the first x. Now, we don't have our y's here. We have our x's. All right, this is our first x, and that's our second x. This is telling us the interval, in interval notation. Let's look at where we're at on the graph. So an x value of 0, it's going to be this point. That's the point 0, 1. The x coordinate's 0, the y coordinate's 1. When x is 3, we're right here on the graph. An x value of 3 and a y value of what appears to be 4. And now we know our x1, our first x coordinate and our first y coordinate, our second x coordinate and our second y coordinate. And now we can plug in the formula. When we do that, the second y coordinate's 4, the first y coordinate's 1, second x coordinate's 3, and the first x coordinate is 1. The top, I don't need a calculator for this one. 4 minus 1 is 3. The bottom is 3. The average rate of change is 1. And in this case, it's a little hard to interpret our answer because there aren't any units given in the problem. We don't know what X and Y represent. So on average, we go up 1 unit for every 1 unit over. Okay. So 1 is probably an acceptable answer here since there are not any units. But you could say between 0 and 3, the function averages 1, that's the average rate of change, unit up, that's the output units, per every unit down to the right. That's the input units. So this is, again, the best answer. This answer would be okay. And to be very clear on what's going on here, this is our average rate of change. This is our output units. And this is our input units. So we're still doing the exact same thing as before. And what we'll talk about later, especially for those of you who are getting into business calculus, is that this average rate of change really corresponds to this diagonal line. The line that connects the two dots is a slope. The slope of that line is the average rate of change. That's more getting into the future, but something to look forward to, a little spoiler for anyone, keep you on the edge of your seat. All right, if you're wondering about business pre-calc. And we're going to do one more example, getting some extra practice with finding average rates of change. We've done it in a few different ways before we get into more functional approach. All right, so example 3, we're on a road trip and we picked up our friend who lives 10 miles away. And after doing so, we decided to record our distance from home over time. Find your average speed over the first 6 hours. Remember, average speed, when we talk about speed, we talk about miles per hour, meters per second, feet per second. It's always distance over time. Okay, so the average speed, that's going to be distance over time, which is good because in our table we have distance in miles and time in hours. It specifically says over the first 6 hours, so that's going to be t being an interval from 0 to 6. This is what's known as the element sign. And it just means t is in. So t is in the interval 0 to 6. All right, just shorthand. So to do that, we're only looking between 0 and 6. Average rate of change over the first 6 hours, well, that's going to be the y value after 6 hours minus the y value that we started with over the x value after 6 hours minus the x value that we started with. So again, we can label, well, we started with this x value, we started with this y value, and after 6 hours, we had this x value. Technically, these are t and d. But to simplify the formula, we can still call them x's and y's if you'd like. So the second y value is 292 minus the first y value of 10. And this corresponds to us saying that we've gone 282 miles in those first 6 hours. And the denominator is 6 minus 0, which means 6 hours have passed. So we get 282 over 6. I forgot to add white space for this problem. And 282 over 6 is 47. Our average speed in the first 6 hours is 47, but we need the units. Whenever we find average rate of change, the units are the output units, miles, divided by the input units, hours. And then in this case, we usually say miles per hour. We don't say hours. Or you could write mph. Whenever you're doing answers for rates of change, or basically any question that's involving real life, giving your answer in a sentence is important. Okay. If you're ever curious or doubtful about what I'm expecting, just ask me. That's it for this video. It was a little long, but I wanted to make sure to give you guys plenty of examples. Hopefully the examples helped and you can do some problems on your own now. And otherwise, reach out. Let me know if you have any questions. And she's still sleeping. Okay, bye-bye.